Okay, so we'll take a look at the second part of parabolas. When we look at the second portion, which is kind of the back side of that, you'll notice that these are not in the nice, easy graphing form. This is in the standard form, and we want to go to the vertex and all that kind of stuff. So the first thing that I'm going to do is I notice that x is squared, so I'm going to keep the x's on one side, and I'm going to move everything that is not involving x to the other side. And what we're going to do is we're going to complete the square. And so since half of 8 is 4, actually negative 4, and square that I get 16, I'm going to add 16 to both sides. That would create a nice perfect square. So on the left side, I've got x minus 4 squared. And on the right side, I've got 8y minus 24, which I could factor that out because of how this works. So that tells me that my vertex is at 4, 3. And that if 4p is 8, that makes p the number 2, right? Because 4 times 2 is 8. And since it's an x squared that is positive, it is opening up. I know that. And so I'm going to move up 2 units from the vertex to get to the focus. And I'm going to move down 2 units behind it. So remember, the vertex was right here at 3, and if I went down 2 units, it'd be at 1. So that's y equals 1, and that is my vertex, focus, and directrix from that version. All right, so now coming over to here, you'll notice that the second problem is definitely a y squared. So again, just like before, I'm going to group the part together that has the square. And to complete that square, I'm going to add 25 to both sides. That's going to generate a y minus 5 squared on the left and a 6x minus 15 on the right. Now, it turns out this is one of those things that just happens sometimes, that you don't always get perfectly pretty values. 15 divided by 6, if you factor out 15, 6, that's both divisible by 3, so that's 5 halves. So that doesn't feel good to a lot of people, but that is our vertex. 6 times 5 is 30 over 2 is 15. And so that looks like my vertex is at 5 halves, comma 5. And it's very common for people to mix these up, especially when y is written first. This way, make sure you put x always as first and y second. This is definitely a parabola that is opening to the right because y is squared and it's positive. If 4p is 6, then p is 1.5 or 3 halves, if you will. So I'm going to move to the right. Again, vertex is here, focus is to the right. If I move over 3 halves, I'd have 8 halves, comma 5. I wrote it that way so you could see what's happening, but a better answer would be 4 or 5. And then if I go backwards 3 halves, I'd be at 2 halves, or in other words, x equals 1. And that kind of finishes off that problem. And so we'll just do one more, and this is the one that is actually a little bit less pleasant. We've got some kind of gross looking numbers at play. So I don't really particularly enjoy this 9 sitting right here. We haven't dealt with that before. So we're going to go through and we're going to divide every single piece of this problem by 9. So 12 over 9 is actually 4 over 3. 54 over 9 is 6. And 104 over 9 is, I guess that's just 104 over 9. That doesn't actually reduce very nicely. So I do want to go ahead and move everything that does not have an x in it to the other side. We're going to take this thing right here, half of 4/3 is 2/3, and we're going to square that 2/3, and we're going to get 4/9. We're going to add that to both sides. So that leaves me with x minus 2/3 squared. Remember, this is the half. And then I need to figure out what is 104/9 plus 4/9 is actually 108/9. But 108 over 9 is exactly, as it turns out, the number 12. And I kind of did that on purpose. So that's 6y plus 12, or in other words, 6 of those y plus 2's. So it appears then that our vertex, again, we've got a positive value with a positive here as well, so it's opening up. So my vertex is at 2/3, comma negative 2. My focus is exactly, let's see, if 4p is 6, that makes p 3 halves, or 1.5, if you will. So if I move up exactly 1.5, from -2, I'm going to be at -1/2. And that again is my focus. And of course, the directrix is going to be sitting back here exactly 2 units, exactly 3/2 of a unit down. And so that's going to be the line like, so this is -4/2. Take away 3/2 would be -7/2. And that would be the backstop value down here. Remember, horizontal lines look like y equals, vertical lines look like x equals. And there we go. And I think that should finish up what we needed to do for the equation of parabolas, both through standard form as well as vertex form. All right, I'll see you back in class.